Hi everyone, this video is on the mixed exercise 9 question 41. The mass of a radioactive substance T years after first being observed is modeled by the equation m is equal to 40 e to the power of minus 0.244 t. In part A, we want to find the mass of the substance 9 months after it was first observed. Okay, so we first need to remember that this T shows basically the years after first being observed. And for example, if you want to look at the mass of the radioactive substance 2 years after first it was observed, then T is equal to 2 because each T is equal to a year. But in this case, what's happening is that this 9 is not 9 years to substitute 9 into the equation, it's 9 months. And we need to see how can be written, because when we have 9, we can't obviously write 9 here, but that's 9 over 12, right? Because we want to know how can 9 be written in terms of a year, 9 months, how can be written in terms of a year, and that's equal to 0.75. So this means in this case, 9 months is equal to 0.75. And that's the value of T for part A. So we just substitute 0.75 into the equation. So 400 to the times e to the power of minus 0.244 times 0.75. So that's basically what we should do for the first part. Sorry, here the equation is actually 40e, not 400. So that's 40e. So the answer is equal to 33.31 to 2 decimal places, and that's basically the mass of the substance 9 months after it was first observed. And this is basically the units that is not given in the question. Okay, for part B, we want to find the m by dt, which is the derivative of this equation, the equation of the mass. So it's an exponential function, and we first differentiate the power, and that comes down as a coefficient. So the derivative of power is simply minus 0.244, so that comes down as minus 0.244 times 40, because we had 40 from the beginning, and then this times the e again, which is e to the power of minus 0.244 t. And this is equal to minus 9.76 e to the power of minus 0.244 t. So that's the derivative. Okay, part C. In part C, we need to interpret the significance of the sign of the value of the m by dt. So the sign of the value of the m by dt is obviously negative, right? And simply because remember the m by dt is the rate of change of the mass. And when it's negative, that just means that the mass is decreasing over time. So when the rate of change of anything is negative, that means that a specific quantity is decreasing over time. And when it's positive, it means it's increasing. So we can simply say that the mass is decreasing. The mass is decreasing. Okay, that's it for this video. Thank you for watching.